This is a salt of a weak base, so I'm going to take a weak base, make a salt out of it. I'm going to choose HONH2, so the formula is 1.00 molar HONH3Cl04. Okay, so you need to recognize this is a salt, and that could be hard on there. So the salt reacts, HONH3Cl04, and it gives us one-way arrow, HONH3 plus Cl04 minus, and we make our if table, 1.00 here, 0 for the HONH3 plus, and 0 for the Cl04 minus. So 0 for our initial amount. Now HONH3 Cl04 finally is 0. The HONH3 is 1.00, and the Cl04 minus is 1.00. Now, out of this, the HONH3 plus is an acid. So I take that and react it with water. HONH3 plus water. And again, this is reactions everybody should be familiar. Double arrow because they're all weak. HONH2 plus H3O plus. And we set up a nice table, initial change equilibrium. This is 1.00 HONH3 plus to begin with. Water we don't care about. 0 HONH2 and 0 H3O plus. Minus X because we don't know how far this goes. Minus X for the water. X and X. And 1.00 minus X. We don't care about the water. There's X, a ton of it. And X and X. So this is an acid. So Ka is equal to the concentration of HONH2 times the concentration of H3O plus divided by the concentration of HONH3 plus. And what I note is this is a Ka, and I don't have a Ka for HONH3 plus. But I do have a Ka for Kb for its conjugate base. So I use this Kw equal Ka times Kb. So Ka is equal to Kw divided by Kb. And I plug my numbers in. Kw is 1 times 10 to the minus 14th. Divided by Kb for HONH2, and I look it up, hydroxylamine is 1.1 times 10 to the minus 8th, so that equal 9.09 times 10 to the minus 7th. So I now have a Ka for this thing. This is going to be useful because I can plug that Ka in up here in my equation. So now I plug in values. Ka is equal to X for HONH2 and X for H3O plus divided by 1.0 minus X. You guessed it, assume 1.00 minus X is approximately equal to 1. Okay, so Ka becomes X squared over 1. I plug my values in for this, 9.09 times 10 to the minus 7th equal X squared over 1. So when I do my math, X equal square root of 9.09 times 10 to the minus 7th, X equal 9.53 times 10 to the minus 4. I'm going to have to do some erasing here. Hang on. X equal 9.53 times 10 to the minus 4, and that's our concentration of H3O. So pH equal the negative log of the concentration of H3O plus. This is pretty easy. So pH equal the negative log of 9.53 times 10 to the minus 4. It's almost 10 to the minus 3, isn't it? So that should be between 3 and 4. So we take the log, negative log negative log of 9.53 to the negative 4 power, and I get pH is equal to 3.021. Circle our answer. We're good. Okay, so there you have it. 4 different methods. This is the 4th one.